All right, so this law is the ideal gas law, and this law introduces the fourth factor affecting gases, so it introduces moles. So this is the first time that we're going to see moles in the equation. All right, so in the ideal gas law, you have the variables for pressure, you have volume, you have temperature, all of which we've used, and now we're using N, which is moles. So the ideal gas law is a combination, and what it is it's based on Avogadro's hypothesis. And Avogadro's hypothesis says, hold on, let me catch up. Hypothesis says that any gas will behave in the same way. Any gas behaves the same at any temp, pressure, and volume. So what he's saying is that it does not matter what gas you have, that at a specific temperature, pressure, and volume, you will have the same amount of moles, because it is a factor of, the gases are a factor of the temperature, pressure, and volume. So the ideal gas law is this: PV equals nRT. Some people sound it out, and that's how they remember it. Other people come up with different ways of remembering. So ideal gas law has some very specific units. So you do have to be aware of your units for this one, okay? T, we've been dealing with all along, is in Kelvin, okay? And N is moles. V is volume, and the volume for this equation has got to be in liters. And P is pressure, and you have two choices here. You can have ATM pressure, or you can have kPa. So that is it. You may not have millimeters mercury or torr or anything else. You need to convert to either ATM or kPa. R is a new factor. R is the gas law constant. And what it is they have taken and considered all the factors to make this equation work and come up with a specific number. And if you choose to use pressures in ATM, your gas law constant is 0.0821, and this is liters ATM over moles Kelvin. If you choose to use pressure in kPa, your value is 8.314, and this would be liters kPa over moles Kelvin. Okay, these units are compound to make the whole equation work, and this organization is what allows this number to work. All right, this sample problem says a cylinder of gas has a volume of 1.5 liters, a pressure of 99.8 kPa, and a temperature of 25 degrees Celsius, and it wants to know how many moles are in that cylinder. So we have a pressure of 99.8 kPa. We have a volume of 1.5 liters. We have a temperature of 25, but again, we have to add our 273, so it becomes 298 Kelvin. And they want to know moles. So we have to come up with what R value we're going to use, and our R is dependent on our pressure. So you can see that we have kPa's here. So we are going to have a pressure of, we're going to have a gas law constant of 8.314. And all we need to do now is plug all these numbers into the equation. So it's PV equals nRT. Our pressure of 99.8 times our volume of 1.5 equals our N, which is what we're looking for, times our 8.314 gas law and our 298. And so when you solve this, you're going to multiply the left side and multiply the numbers on the right side, and then do some division. And when you do that, you get the amount of moles is 0.06 moles. Now, you can be asked to solve for any of the variables. You can be asked to solve for pressure, for volume, for moles, or for temperature. Okay, so there are some alternate equations. We've been dealing with PV equals nRT. And if you think about it, you have a volume and you have a you can figure out perhaps a mass. And so there can be a couple other things that people can ask you to do. Moles is really the mass per sample. So you could be solving for PV equals little m over big M RT, where the little m is the mass of the sample and the big M is the molar mass. Or you could be asked to solve for PM equals DRT, where the D is the density and the M is still the molar mass. All right, it's homework time. So you will be solving this problem and submitting your work and your answer into the Ideal Gas Law Schoology file. And so it says a balloon has a volume of 537 milliliters, a pressure of 1.03 atm, and a temperature of 22 degrees Celsius. And it says how many moles are in this balloon. So you are solving for the number of moles. Again, make sure you submit it into the Ideal Gas Law assignment in Schoology.